Yeah, what I was telling you that which principle or rule limits the maximum number of electrons in an orbital to 2? That is Pauli's exclusion principle. It is Pauli's exclusion principle which states that maximally 2 electrons can be there in an orbital. Fine, in an orbital.
Yes.
It is Pauli's exclusion principle. Now see the next one. The first energy level that can have d orbital is
3.
third shell. Fine, very good. 1, 2, 3. In first shell only S subshell. In second shell it is S and P both.
S and P.
And in third shell it will be sp and d orbital. So it d orbital
Yes.
containing first energy level will be third energy level only. So this will be the answer. Good. Which set has the same number of unpaired electrons in their ground state? Out of these four sets, which set of elements will be having the same number of unpaired electrons in their ground state? See, nitrogen is having 3 unpaired, phosphorus is having 3 unpaired, and what about vanadium, scandium, titanium, vanadium? Scandium, titanium, vanadium. Vanadium is 23 now. 23 means 4s2 3d3. How many unpaired electrons are there? 3. Nitrogen and phosphorus are having 3 unpaired electrons, and vanadium is also having 3 unpaired electrons. So answer will be A.
First.
In sodium 1 unpaired, in phosphorus 3 unpaired, and Cl 1 unpaired. So Na and Cl will be having same number of unpaired electrons, but phosphorus will be having 3. Here Na plus is having 0, Mg2 plus is having 0, and Al will be having 1 unpaired electron. Cl minus will be having 0, Fe3 plus will be having 5 unpaired electrons, and Cr3 plus will be having 2 unpaired electrons. So it is A only which is having the same number of unpaired electrons. Now see PD2 plus. You know what PD is? We have done this there on the last day. That what
Palladium.
PD is 4s0 3d10. What PD2 plus is 4s0 3d10. So if it is losing 2 electrons, then will become 3d8. Will become 3d8. So see, sorry, 4d8. I have said
4d8. 4d8.
5s0, 5s0, 4d10. So this will be 4d8. So this will be the answer. 36 plus 8, 36 plus 8 will be 44. Its atomic number is 46. After losing 2 electrons from 5s, it will be having 44 electrons. So this is 44. So answer will be fourth. Question number 4, answer will be A. Now see question number 5. What will be the answer?
S electrons. Sir, 1 minute.
Yeah. On.
Not getting.
See, I'll tell you. Which set has the same number of s electron? See, what your first option is. First option is carbon 1s2, 2s2, 2p2. How many s electrons are there? 4. How many s electrons are there? 4. C, Cu2 plus. Cu2 plus will be having 1s2 and 2s2, 3s2 and 4s0. So how many s electrons will be there? 6. And what about Zn? What about Zn? Zn will be having 1s2, 2s2, 3s2 and 4s2. So it will be having 8 s electrons. So this is not the right one. Now see the next one. Cu2 plus. Cu2 plus will be having 1s2, 2s2, 3s2 and 4s will be 0. And Fe2 plus. Fe2 plus will also be having 1s2, 2s2, 3s2 and 4s will be 0. What about Ni2 plus? Ni2 plus will also be having 1s2, 2s2 and 3s2. Since they are asking only about s electrons, since they are asking you only about s electrons, just write only s electrons. No p, no d. So this will be the answer B, because it is having the same number of s electrons, that is 6.
Yes.
That is 6. Fine. So see,
Yes.
in all such questions, we need to do all these things very, very fast. You won't be having
Yes.
time to do that 1s2, 2s2 or what the atomic number of this or that. So you have to be very prompt. That is why we have done all those 12 points, so that you won't be taking time. If proper revision is there, then you will be doing it very, very fast. Now see the next question.
D.
Next question. Correct outermost electronic configuration of
D.
chromium.
D.
Yeah, very good. D. 4s1. This is 4s and this is 3d. So it is exception to above principle. So electronic configuration will be number of orbits. And see, wherever we are making mistakes now, just highlight all such questions and keep on doing all such questions.
Yes.
Number of orbits and orbitals having electrons in 14 Si are respectively. See what Si is. Si is 1s2, 2s2, 2p6, 3s2, 3p4, 2, 4, 10, 12. Sorry, 3p2, 2,
10, 12.
4, 10, 12, 14. Fine,
Yes.
14. So how many orbits? Number of orbits are 1, 2 and 3. Number of orbits are 3. So in this
3.
only 3 and in D only 3 is there. Now see how many orbitals are there. So see 1 orbital, 2 orbital and 3, 5, 5, 6, 6 plus 2, 8. 8 orbitals, na? 3p will be like
Yes.
this now. So they are asking.
Sir, I can't see what you've written.
Means it is finely written, or what exactly it is? You are doing this there in mobile?
Yeah. No, sir, now it's visible.
Okay, now it is visible.
Yes.
Okay, fine. So see, they are asking you number of orbits and orbitals having electrons. You need not to count this one. Fine. Need not to count this one. So 1 orbital, 2 orbital, and in P3, so 3, 4, 5, 6 and 2, 8. So this will be the answer. D will be the answer. Is it okay? D will be the
Sir, I didn't get this 8 one.
7th one or 8th one?
8.
8, fine.
How you got this 8?
Yeah, fine.
I'm confused.
Oh, second part of this question.
Yes.
See, what will be the electronic configuration of Si14? 1s2, 2s2, 2p6, 3s2, 3p2. In 3p, it will be like this now. This is 3p now. Here,
Yes.
in 3s, how many orbitals are there? 1.
1.
In 1s, how many orbitals are there? 1. In
1.
2s, again, how many
1.
orbitals? 1. In 2p, how many
3.
orbitals? 3. Then again 1. And then here, 1 and 2. So see,
2.
1,
Okay.
2, 4, 3, 4, 5, 6, 7, 8.
Okay.
Now, is it okay?
Yes, sir.
So you have to see only those orbitals which are having electrons, that we need to write. Now see, what next is? What next is question number 8. Number of d electrons in Fe2 plus. Fe2 plus.
2 plus.
Fe2 plus means 4s0, 3d6.
6.
Now what they are asking you, the number of d electrons in Fe2 plus is not equal to that of the. See, in 3D, how many electrons are there? 6. So now they are asking
6.
you out of ABCD, which will not be having 6. Here it is S electrons, here it is P electrons, here it is D electrons, here it is P electrons. So see, in Fe also 3d6 is there now. In Fe
Yes.
also 3d6 now, 4s2 3d6. So here it is 6, there also it is 6. So they are asking you not equal to. This is equal now, so this
Okay.
can't be the answer. P electrons in neon, helium, neon, 10, 1s2, 2s2, 2p, 6.
6.
In neon, P is having 6 electrons now. This is also
Yes.
having 6 electrons in D subshell. So this is also not equal. Now see, S electron in Mg. What Mg is? 1s2, 2s2, 2p6, 3s2.
3s2.
Here 2, here 2, here 2. They are talking only S electrons now. So 2, 4 and 6. So this also can't be the true. Is it fine?
Yes, sir.
Now see, D electrons in Cl, sorry, P electrons in Cl minus. Cl minus is 1s2, 2s2, 2p6, 3s2, 3p6. Is it okay? 2, 4, 10,
Yes, sir.
12, 18. Cl minus 18 na? Cl
Yes.
minus 18 na? Here 6 electrons and here 6 electrons because they are asking you
12.
P electron. So it is 12 na? But it was having
Yes,
6
sir.
electrons D in D subshell. So this will be the answer.
Answer.
Is this okay?
Yes, sir.
In all such questions, we have to be very prompt. Then only we can solve. Because if we will be taking more time, then can again be a problem. Now see the next one, H minus. This is what we did there
1s2.
in our last 1s2. Fine, very good. This will be the answer. So easy. An atom having even number of electrons may be, what it would be?
Diamagnetic.
Dimagnetic. C. Carbon 6 atomic number is even now.
Yes.
What will be its electronic configuration? 1s2, 2s2, 2p2.
2s2.
It is having unpaired electrons now.
Okay.
So will be paramagnetic. So even can be
Diamagnetic
para
or
di.
paramagnetic.
But odd can never be dimagnetic. That's for sure. Odd number of electrons containing species can never be dimagnetic, but even number containing can be dimagnetic or can be paramagnetic.
Paramagnetic.
Is it okay?
Yes, sir.
But odd can never be dimagnetic. Will always be paramagnetic only. Now see. What about this next question?
Number of neutrons present.
Number of neutrons present in 1939
39 minus 19.
will be 20.
20.
So this will be the answer. Is it okay?
Yes, sir.
Now see the next question.
How many unpaired electrons in Ni2 plus?
Ni2 plus, you know what Ni2 plus is? 28. 28 means 4s0, sorry, 4s2, 3d8. 4s2, 3d8.
Yes, 3d8.
And you have taken
two
out
unpaired.
2 electrons. You have taken out 2 electrons. So it will be
Okay, so it will be 6.
3d8 now.
3d6.
No, not 3d6. That those 2 electrons will be lost from the last shell. Which is the last shell? 4s.
Sorry, sir. Yes.
Last shell
4s03d8.
4s03d8. So 2 unpaired electrons. So this will be the answer. Now, this 13th question number 13, in which case above principle is violated? Here is a spelling mistake. I have written by mistake only that T is
Yes,
added
sir.
there in that AUF, DAU. There is a above principle. So, which is the violation
A
of
answer. A.
A or B?
B. Sorry, B.
B.
Sir, both. No.
Nana, A is violation of Hund's rule.
And okay. Yes.
A is violation of Hund's rule, and
Hund's
D
rule.
there is no violation. C also no violation. Only in A and B violation is there, and since they are asking you above principle, so B will be the answer, and A will be the exception to Hund's rule only.
Hund's rule.
So they are asking you but above principle, so that's why answer will be B. So now nitrogen atom has 7 electrons. The nitride ion will have
7 protons, 10 electrons.
pardon, which will be the answer?
A. A.
A, 7 electrons. So in atom, 7 electrons are there. So
protons.
7 protons will be there. But ion, what they have given is N3 minus. N3 minus means 7 plus 3 electrons. So it will be 10 electrons and 7 protons. So this is the answer.
Yes.
The valence orbital configuration of an element with Z is equal to 23 is atomic number 23. What will be its configuration?
4s3d3.
4s2 3d3. Yes, very good. This will be the answer.
Li 2 plus 3 plus 4. Isoelectronic.
So electronic, because both will be having
Yes.
1 electron only. Because both will be having 1 electron only. Lithium is 3. 3 minus 2 will be 1. And beryllium is having 4. So 4 minus 3 will also be 1. So will be isoelectronic species. Fine.
Yes, sir.
Now see 17th. See, all these questions are very easy. But the main thing, you will be taking a lot of time. So that is why 12 points are so important. That's why you should be perfect there in 12 points so that you can do all these points very, very fast.
Yes,
This
sir.
paper I prepared for Professor K.C. Sinha classes there in for them only I prepared this question paper. So what will be the answer there in question number 17? What will be the answer there in question number 17?
S and P.
Yeah. Number
Nitrogen.
of S and P both must be same. In question number 17, what they are asking you, tell the name of the atom which is having same number of S electrons and P electrons.
Mg.
Mg. See, we will check it. Mg 12. 1s2, 2s2, 2p6, 3s2. See how many S electrons are there? 6. And how many
6.
P electrons are there?
6.
6. So S and P both are same in number. So answer will be magnesium.
Mg.
Fine. Very good. Now see, these type of questions they may ask us there in entrance exam. What will be the question number 18? Krypton 36.
Subshells.
Krypton 36. 37th electron will go into which of the following subshell?
So now will 37th electron.
See, 1s2, what we need to do, you have to write this. above principle 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. What they are asking you, which will be the next subshell? This is what they are asking you. 2, 4, 10, 12, 18, 20, 30, 36. What would be the next one? Next one will be 5s now.
Yes, sir.
Next one will be, so 37th and 38th
5S.
electron will be
5S.
into 5s. So 5s.
5S.
They were asking you what comes after 4p. This was the
Okay.
meaning. An atom has net charge of -1. It has 18 electrons and 20 neutrons. Its mass number will be
I don't know, sir.
C. An atom has net charge of -1 and 18 electrons. So charge is -1
Yes.
means in
So 19.
in atomic state now. In atomic state, it will be having 17 electrons. After having minus charge, its electron is 18 now.
Yes.
So atom will not be having any charge now.
Yes.
So atom will be having
So-
one electron lesser than this now.
Yes. Yes. Sir.
Whatever the number of electrons are there, that many protons will be there now. So 17 protons and 20 neutrons. So it will be 37.
47.
Fine.
Yes, sir.
It will be 37. Now see question number 20. Now question number 20. Which neutral atom has 18 electrons in its outer shell? Should not take this much time. See, 18 electron in its outer shell. Should I start?
Yes, sir.
A is Cu1 plus. What Cu1 plus is? 1s2,
20.
2s2, 2p6, 3s2, 3p6, 4s0, 3d10.
3D.
See, this is the last shell which is having 2, 8 and 10, 18 electrons.
Okay.
After this 4s will be losing 1 electron because it is 1 plus charge now. So this third
Yes.
shell will become penultimate. This third shell will become valence shell, and in this valence shell of Cu1 plus 18 electrons will be there. 2 plus, 6 plus, 10 plus. That is 18. So Cu1 plus will be the answer. Fine. Here in valence shell,
Yes, sir.
2 electrons. Here in the valence shell, 2 electrons. Here in
2
valence
electrons.
shell, in the valence shell, that we need to check. In valence shell, how many electrons? Oh, sorry. Cu1 plus is not the answer because they have said neutral atom. And Cu is not neutral atom, na? It is 1 plus. Palladium. See what palladium will be having. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s0, 4d8. Sorry, 4d10. So this is fourth shell, 2, 8 and 10, 18. Palladium will be the answer, not copper. Why? Because copper is neutral, not neutral now, and they are asking you neutral atom. So copper can't be the answer. Is it okay?
Yes, sir.
So what next is? The total number of unpaired electrons in an unexcited atom of atomic number 29 is. How many unpaired electrons are there in this? Cu.
Copper is 29.
Copper is 29. Yeah.
4s2, 3d10.
4s1 3d10.
4s. 1 unpaired electron.
1 unpaired. Which electronic configuration does not follow the Pauli's exclusion principle? Means out of all these configurations, which is the one in which Pauli's exclusion principle is not followed?
D.
Yeah, there you wrote 3s3 na. 3s can't have any one orbital, can never have more than 2 orbitals. Maximum number of electrons which can be present there in an orbital is 2. Here they wrote 3s3. So that's wrong. Fine. Good. Next. Question number 23. The magnetic moment of electron in an atom, excluding orbital magnetic moment, is given by
B.
B or A?
N plus 2 eta into eta plus 2.
B or A? Eta plus 2 or eta plus 1?
Plus 2. I don't know.
Yeah, it will be plus 2. Not plus 2. Fine.
Yes.
It won't be plus 1. It will be plus 2 only. Fine.
Yes.
See, root 3. When you will get root 3, when unpaired electron will be there, na? 1 plus 2 will be 3. 3 into 1 will be 3. Root 3 will be 1.732.
1.7.
1.732, that is 1.8 approximately. So answer will be,
Yes.
answer will be A, not B. Answer will be A,
B.
not B. So that's what will be the 24? See how easy it is.
Chlor.
See how easy it is. Yeah, please tell me.
Chlorine. D.
D. Cl plus 17 electron. Now 1 electron will be lost. So how
Yes.
much is 16? This is also having 16. So 24 would be D. What about the electronic configuration of niobium 41?
Niobium.
We did this there on Saturday.
Yes, sir. 5s2 4d3.
Yeah, according to our principle, it should be 5s2 4d3.
5s0.
But it is an exception. Instead of 5s2, it is 5s1.
5s1 4d4.
Not 5s0. Right?
Yes.
5s0 4d4.
5s1.
Just only one electron will be transferred from ns subshell to n-1d subshell. Only one
Yes.
electron will be transferred. Now see what the next step is. The atomic number of an element is 35 and mass number is 81. Then how many electrons are there in the outermost shell? See, for such questions, what you should know: fluorine, fluorine, bromine, iodine. This is 9, this is 17 plus 18, 35. So they are talking about this. Fine. They are talking about
Yes.
this. They are talking about bromine. It is fluorine, fluorine, bromine, and iodine. All are there in the 7th A group. So in the valence shell, how many electrons will be there? 7.
46, 7. Yes.
They are there in the 7th A group now, because 7
7.
valence electrons are there in the last shell. Now what about the next one, 27th one?
Compound the element with atomic 43 in the same practical particle.
Should I tell you answer?
Yes, sir.
TC is 43. Subtract 80 from 43. What you will get? You will get 25 now. So which element is
Yes.
25? 25 is manganese now. What manganese?
Manganese.
Is 4s2 3d5. What manganese is 4s2 3d5.
3d5.
3d5 electrons. So this is the one which is having 4s2 3d5.
Yes.
We'll be looking for 3d5 there at the last position, but nowhere it is there. So we'll keep on. We can get confused with this too. But answer is B.
Yes, sir.
Fine. Now what
Next number of B.
2n square. That's the maximum number of electrons there in n orbit. Good. Answer is B. Maximum number of electrons in n orbit is 2n square, and maximum number of orbitals in n orbit
5d10.
n square is n square.
5d.
Which one?
5d.
About 29. Okay, 4f. 4f is 70. After 70, what will be coming?
5d.
5. Good. 8. An ion which has 18 electrons in the outermost shell is, which one is having 18 electrons there in the last shell?
Copper plus.
Copper 1 plus. Need not to go further. Now, what next is 31?
The number of electrons. 19.
20. K minus
Minus, yes, 20.
20. What about the next one? Electronic configuration for Fe26 is, what will the configuration of Fe?
4s2 3d6.
4s2 3d6. Need not to work. 1s2 2s2 2p3. How many unpaired electrons are there in this?
How many?
Unpaired electrons. This is paired. This is paired. These are the
Said
paired.
4.
No, 3.
3. Yes, sir.
Paired. This is paired. This is only one subshell 2p, which is unpaired, which is having 3 unpaired electrons. So total number of unpaired electrons is 3.
3.
Right?
These are
3
the
nitrogen. That is
number of unpaired.
nitrogen. 1s2, 2s2, 2p3. That is nitrogen.
Yes.
Right? Now, what the next one is?
Minimum number of unpaired d electrons.
Minimum number of unpaired d electrons.
Sir, cobalt is
What? Which one? B or C? Two cobalts are there, na?
yes.
CO3 plus and CO2 plus. See, this is D5.
27.
This is D5. And what about this one? This one is also D5. This one is also D5.
4s2
And what
CD8.
about this one? This is D7. And this is D6. So in D6, 4 unpaired electrons. In D5, 5 unpaired. Here it's 4. And in this case, 3 electrons will be unpaired. So minimum number of unpaired electrons is 3.
Cobalt 2 plus.
CO2 plus. Fine.
Yes, sir.
Atomic number 56 belongs to which plot?
B block.
Beryllium, magnesium, calcium, strontium, barium,
D
radium.
block, sir.
C. 4 plus 8, 12 plus 8, 20. 20 plus 18 will be 38. 38 plus 18 will be 56. 56 plus 32 will be 88. So this is barium. Na? Barium is second age group. Na? Second age group means S block. Second age group means S block. Is it okay? Fine.
Yes, sir.
Answer will be S block.
S block.
That's why we should be very perfect there in periodic table.
Yes.
Fine. What next with this?
S block.
S block. No,
S block.
no, not S block. 3D2 na. 3D2 na. D is incompletely filled na.
Yes.
This is titanium 22. See here 18 na. 18 and
Yes.
20. 20 plus 2, 20.
22.
It's titanium, that is D block. Fine.
Yes.
What next? This is 4s2. This is 2s2. This is 4s2. 3d10. This is paired. This is paired. This is paired.
Nitrogen.
All dimagnetic. Only nitrogen is having 3 unpaired electrons, so will be paramagnetic. So
Yes.
will be paramagnetic. So so-easy this point was. Now, the valency electrons in carbon atom is, how many valence electrons are there in the carbon atom?
4.
4, that is why its valency is 4. What, which is para?
Yes.
See, should I tell
So
you
can
this?
you explain? Yes.
Yeah. See, odd into even will be even now.
Yes.
Odd. Cl is 17 now, and valence shell will be having 7 electrons now. So odd into odd, even, and even into even, even. So even plus even, even. So this will be diamond. See here, odd into even. Odd into even will be even, and even into odd will also be even. So even plus even will be even. So this will also be diagonal. See, odd into odd, odd into odd, or odd plus odd.
Yes.
Better to say odd plus odd instead of saying odd into odd. See what the atomic number of Cl is. I was saying here odd into odd. No, odd into even. 7 8s are 56. 3 2s are
17.
4. So odd into even will always be even. Even plus even, even. Diamond. Here, odd into even will be even, and even into odd will be even. So even plus even, even. So this will also be diamond. Now see, odd into even will be even, and even plus even will be even. So this will also be diamond. Here see, even into even, even. Here even into even, even, and this is odd. So even plus odd will be odd and will be parametric in nature. So Cl is parametric.
Sir, again, your voice is not clear.
So see what I was telling you. What I was telling you that in Cl2O6, 2 Cl are there. In Cl2O6, how many Cls are there? 2 Cl. And 1 Cl
2.
is having one Cl is having odd electrons. So odd into even. Odd into even will always be even now.
Yes.
3 2s are 3 4s are 7 4s are 7 6s are. So atomic number is odd. And how many atoms are there? Even. So even into odd will be even. And this oxygen is having how many electrons? 8 electrons. So that is even number. So even into odd, odd. Even into odd, sorry. Even into even, even. So even plus even,
Even.
dimagnetic. Now see here. This Cl is having 17 electrons. So 17
Even.
into 2 will be even now. So even. And this
Yes.
oxygen is 8. 8 sevens are 56. So even into odd. Even into odd will be even
Even.
only. So even plus even, even. So this is also having even electrons, so will be dimagnetic. Now see, odd into even. Odd, Cl is having 17 electrons and 2 is even. So 17 2s are 34. 34 plus 8, that is even. So odd into even, even, and even plus even will be even. So this will also be dimagnetic, and they are asking you paramagnetic. Oxygen is having even electrons now. So even into even, even. Even plus odd, odd. So this will be having odd electrons. So this is paramagnetic. Sorry, this is diamagnetic. This is diamagnetic, and this is diamagnetic. It is ClO2D only which
Paramagnetic.
is paramagnetic. Now, what about the paramagnetic nature of any of these species? Which one is paramagnetic?
So again, we have to do the same way.
Yeah, same way. Maths. Odd into odd, odd into even, even into even, like this. Odd into odd. Odd into odd will always be odd.
Yes, sir.
Will
That I
always
got.
be paramagnetic. And even into odd. Even
Even.
into odd will be even. And even into even will also be even. Then you have to see whether 2 or 3 or 4 are there. So what it is summing, odd or even, what it is summing, accordingly we'll do.
So O2
O2, but there is no
minus.
O2, O2 minus
O2
C.
minus, yes.
Yeah, O2 minus C here. This is 8 plus 8, 16 and 117. So paramagnetic. This is C, 6 and 1 electron. So 7. 7 plus 3, 10. 10 is even number na, so diamagnetic.
Yes.
8 plus 6, 14. 14 is even na, so diamagnetic. 7 plus 7 is 14 na,
Plus,
so it is also
yes.
diamagnetic. So this is only one which is paramagnetic in nature. Now see what the next is.
Ionic radii.
Ionic radii. This I think you may have difficulty because 12 points is only done. We have not done. See, the more the number of electrons, bigger will be the radii. More the number of electrons, bigger will be the radii. See here, this is having 8 electrons. This is having 7 and sorry, this is having 10 electrons. This is
10.
having 9 and this is having 7. So which will be having maximum number of electrons? O2 minus. So O2 minus will be the
Yes.
biggest one.
Yes.
Fine.
Yes, sir.
And that's all. This will also be the right one because this is having 54 electrons, this is having 53,
All of these,
and
sir.
this is having 52. No, all of these can't be because A is not the right one.
Fe2 plus.
Fe, just check 56 protons, 56 protons, 56. Here maximum number of electrons, here 24, this is 26, this is 24, this is 23. So protons is same. So the, yeah, B is the right one. B is the right
Yes.
one. B is the right one. B is the right one. Now variable valency is the characteristic of
Non-metallic elements.
Transitional elements only,
minute, sir.
transition metals only, D block metals only. D block metals only. Transition metals means D block metals. So variable valency is characteristic of transitional elements only.
B black. Yes.
Fine. So C, transitional metals. Element having 6 electrons in its outermost orbit generally form. Element having 6 electrons in outermost shell generally form what?
They gain 2 electrons.
They gain 2 electrons to complete octet. So since gaining electrons, so negative charge get developed on that. Negative charge,
yes.
gaining electron
Negative,
means negative charge will be added, will be increasing. So it will be B.
Negative ion.
Yeah, negative ions.
Chloride atom.
Now, what the next is?
Chloride atom differs from chloride ion in number of electrons.
Electrons only. Rest remains be constant. Ions and
Yes.
atom, there will only be difference of electrons.
Yes.
Ions and atom, there will only be difference of electrons.
Electrons.
Other than electron, there will not be any difference. Fine. Now see question
Yes,
number
sir.
45. Which main group elements have a different number of outermost electrons than their group? Which main group elements have a different number of outermost electrons than their group? Here by mistake, halogen T is written, so it is not there.
Yes, sir.
This is also very good question. See, noble gases are having 8 electrons there in the valence shell, but its group is 0.
Yes. Yes.
Valence electrons are 8, but their group is 0. So that is
0.
what they asked you. Fine. Which of the
Yes, sir.
following will act as a metal and sometimes as a non-metal?
Mercury, Hg.
No, it is always metal. It is astatine only. Astatine only. Now I'll tell you this point. I'll tell you here this point. C. Boron, aluminium, gallium, indium, thallium. Carbon, silicon, germanium, tin, lead. Nitrogen, phosphorus, arsenic, antimony, bismuth.
Bismuth.
Oxygen, sulfur, selenium, tellurium, polonium. Fluorine, chlorine, bromine, iodine, astatine. Then here it is helium, neon, argon, krypton, xenon, radon. Now see the atomic number 5, 6, 7, 8, 9, 10. 2 plus 8, 10 plus 8, 18. 18 plus 18, 36. 36 plus 18, 54. Plus 32 will be 86. This is 85. This is 84. This is 83. This is 82. This is 81. 5 plus 8, 13. 13 plus 18, 31. 31 plus 18, 49. 49 plus 32 will be 81. 13, 14, 15, 16, 17. 31, 32, 33, 34, 35. This is 49, 50, 51, 52, and 53. Is this all okay?
Yes, sir.
Now see, like as steps, go like this, like as steps. Now see, in first box, only one, in first step, only one box. In second step, 2 box. In third step, 2 box. In fourth step, again 2 box. And in last step, only 1. This is 1 element. Here it is 2 elements, 2 elements, 2 elements, 1 element. So 2, 4, 6, 7, 8. These 8 elements are there in P block, and these 8 elements are metalloids. These 8 elements are metalloids or semi-metals. These 8 elements are metalloids or semi-metals having properties of metal as well as non-metal. So from which this first element is, that first element is boron. Second is silicon, germanium, arsenic, antimony, tellurium, polonium, astatine. These 8 elements are metalloids. These 8 elements are semi-metals, having the properties of metals and non-metals both. And all these elements
Yes.
which are placed on the left hand side, this strip on the left hand side, whatever elements are present, these all elements are called metals, and elements
Metals.
which are present there on the right hand side are called
Non-metals.
non-metals, are called non-metals.
Metals.
So see here, bismuth is having 5 electrons there in the valence shell, but it is placed on the left hand side of this strip of 8 elements now. That's why it is metal. Tin and
Metals.
lead are having 4 electrons there in the valence shell. Even after having 4 electrons there in the valence shell, then also are metals, because these are placed on the left hand side of this strip. Fine, is it okay?
Yes. Yes, sir.
Now, what was your point? We will go back. What was your point? We will go back here. Here, which will be acting as a metal and as well as a non-metal. Which is acting as a metal
Acetylene.
as well as non-metal. Which one?
18.
Acetylene. Very good. That's why I'm insisting a lot to all of you that you should learn periodic table. Then only you can manage all these points. So what will be the answer? Answer will be astatine. Astatine 85. Astatine 85 is having
85.
metallic as well as non-metallic both properties. And it is not a astatine.
Yes.
Atomic number is 85 now. So it is not a true halogen because it is radioactive now. It is radioactive
Yes.
now. So do not found in
Yes.
earth crust. Do not found in earth crust. It is radioactive in nature. So do not found in earth crust. And it is having the properties of, but it is having the properties of metals as well as non-metals both. Fine. So
Yes.
this is all over. What next is?
In a multi-electron atom, the energy of
A 2p orbital is. In a multi-electron atom, the energy of a 2p orbital is. The energy
less than
of a
2s.
2p orbital will be more than that of 2s comes first na, then 2p. 2s comes first na, 2s
More than 2s orbit. Okay.
yeah, 2s and 2p na, so 2p will be having more energy, so more than that of 2s orbital. 2s will be having lesser energy.
Yes, sir.
Now see, question number 47 is over. Now question number 48.
D.
D, containing unpaired electrons. Yes, very good. So easy it is. So it's a state of mind. If you know entire periodic table and if you are having proper practice, then you will be doing all these questions just in 30 minutes only, or less than 30.
Yes.
Just only 2-3 questions are there where you need to put efforts. Otherwise, in every question, it is so easy. What next is 49 is
D, sir.
D. Cu2 plus. Yes, very good. Yes, very good. Neither atomic number, non-atomic mass, nor equivalent weight. None of them will get changed. Just only valence electrons will get changed. Very good. What the last one is?
The sign of ionic species is electron.
Here I'll tell you one point. Here I'll tell you one point how to do it. Although it is not required here to discuss, but see. More the number of electrons, bigger will be the size. Fine. More the number of protons, lesser will be the size. Here protons must be same, and here electrons must be same. Then only this point will be right. Then only point will be right. So laterwards I'll tell you reason also. Then we will discuss now this last question. See here, this is having 10 electrons. And what about protons? Protons are 17. And what about this one? Sorry, 10 electrons. What about Si4 plus? 10 electrons and 14 protons. 10 is same. In this case also 10 electrons.
10.
And protons will be 12.
This also
in
10.
This also 10 electrons and
11.
protons will be 11. See, which one is having which one is having electrons are same. So don't discuss
Yes.
about electrons. Fine. Electron is not
Protons,
the deciding
yes.
factor. Na? Just talk about protons. More the protons, smaller will be the size.
Lesser.
So this is biggest they have written. This is
So
biggest.
Na
but-
will C answer,
but-
sir.
so this will not be the right one.
Na,
Here,
Mg,
Mg, no, not this two.
S9, Na
This will be the
B,
answer.
sir, B.
This will be the answer, B. This is having
Yes.
minimum number of protons now. Then this is 11, this is 12, this is 14, this is 17.
14,
So,
17.
so B will be the answer.
Yes.
B will be the answer. Fine. So just
Yes, sir.
practice like this. I am having some more papers too, questions too. So like this, they will be asking you question. Fine. After 2-3 days,
Yes.
we will be having a test on this all. Fine.
Okay, sir.
It may be possible you will be getting questions from here, or it may be that something new you will be getting. Fine. So just today it is Monday. So on Thursday, we will be keeping a test of this all. So please be ready. Fine.
Yes, sir.
So where you will get questions based on these points which we have done up till now. See, you might be having that solved papers or unsolved papers of previous years now.
Yes.
So their atomic structure, periodic classification, chemical bonding, hydrogen, S block, P block, D and F block, coordination chemistry. From all these chapters, you can get the questions based on this all. So just to go through this all so that because there I'll be giving you less time. I won't be giving you 1 hour for all these 50 or 52 questions. There I'll be giving you 30 or 35 minutes like this. Fine. So just to practice a lot. Fine. Okay, that's all for today. Thank you very much.
Sir, can you send me this PDF?